right, so now you can see my full screen, I guess. One comparing to the previous, so in the previous paper, we didn't explain how these targets could be placed. So again, this is about this project is developed in the Ensner project. There were plenty of co-authors in this research. Wenlan, Shen, Soroush, Fazeli, Weihang, Hükar, Suci, Runfeng, Phillip, Hübner, Nikhita, Kurupakulu, Venkat, and Professor Thomas Bock. So this is the introduction. We find some research gaps. There is an approach and some conclusions. So what we, as I said again, what we need, since I didn't know that both presentations would be one after the other, I just placed this again. The point is we need to place these targets on the facade manually, right? Of course, placing these targets manually, you need a platform in the end, and two operators, at least two operators. This is very time consuming, so then we thought, okay, why don't we use a UIV for placing these targets? And the idea was, let's how we can add an end effector on top of the UIV, and how this UIV can be robust enough so there is so many deformations in the UIV. So therefore, first of all, we made some sort of a design of the UIV. This design is not the best in the picture, well, but anyhow. But the point was we don't want extreme forces to occur when these targets are placed on top of the wall. So basically, we are using ROS as a controller. The hardware, basically, it is this. We are changing this. This UIV is not working anymore. We have to redevelop it because we had, as you might see, the separation of the motors and the propellers was too small, and that's why we had a very unbalanced situation, and the UIV was not able to fly properly. So we are using Raspberry Pis, Nevio 2 as a flight controller, and well, normal motors for brushless motors for I can say also that we are changing the batteries because those were too heavy. The motors that we are showing here are not suitable for us because those are for racing UAVs, and if in our case it doesn't work. We need some more stable motors, let's say. Well, I was not involved in this part of the controlling system. Well, if you have any question about the controller, and I can see that this picture is not the best also for this scheme, but basically what we have, so if you have any question regarding the controller, you can ask me and I can maybe try to answer, but I would need to ask some other person if there is any doubt regarding this. So what we have is a control algorithm, basically, that is depending on some references input that we have. Then these control systems works based on that. We are using an ArduPilot integrated in ROS. Those are the schemes that we are using for the different motors and the geometric control and trajectory tracking. Yes, as I said, we are using ROS, and different hardware is integrated in there. So basically what we have is, and sorry about this picture, I'm realizing that now that is not the best, sorry for that. We have two ways of localizing the UIV with high accuracy. So basically we are capable of placing targets in windows. This is not a problem because those are accessible from the inside. So we can use the targets, April tags that we place in the window manually to localize the UAV has an onboard camera, and this onboard camera localizes the UAVs. Okay, so the first mean of localization for the UAV is that the April tags, these UAVs, give a signal to the UAV, or the better said, give a signal to the computer of the UAV, and the UAV localizes this April tag. So wherever the UAV is moving in this position and is able to check this April tags, or to see this April tags, is able to localize the UAV itself. But we have another mean of localization. We have a ground camera, and we are thinking on placing in the UAV an April tag too. So this April tag could be localized by this ground camera and the computer linked to it. So therefore, we have two means of localizing the UAV. One is by the camera on board, and the other one is by the ground camera. This is the scheme how we are trying to work right now. And this is, well, the initial videos that we were thinking how this drone could be. This on the right, this is a previous version we were thinking doing. So not using a printed April tags, but maybe using some sort of stamps. But this is not working because the ink, of course, doesn't work so properly, and the how to say it, the April tags that it places are not so nice. So as you can see on the video on the link, regarding, of course, when you do simulation, everything works, but now we are facing some issues, and we are trying to do it in our real life. So as a conclusion, and I think I'm now in time, UAV with an end effector was tested, developed, and we are using for construction purposes, and improvements are ongoing. And well, we may have some solution by the end of the year. Thank you very much again, Professor Kim, for hosting this session. And well, I must thank again the ENSNER project. Those are the partners of the project, and it's financed by the European Commission. Thank you very much.